Hello all, welcome to this Pharos and Audio webinar, and thank you for joining. My name is Bas Hoksberg and I'll be presenting today's webinar. My colleague Ryan Sainsbury is available in the background to help out where required. I expect this webinar to be about 45-50 minutes, so slightly longer than normal. If you have any questions, please use the buttons at the bottom of the screen to get in touch. We might answer the questions on the fly or at the end of this webinar. I see a nice list of attendees and hope we can make this interesting for all of you. So in today's session, we'll talk a bit about audio in relation to Pharos. And from this, we'll give several examples. The way how we see audio might not be always 100% correct. You'll see what I mean with that in the next slide. But we try to make it clear for people who ask us, what does Pharos do with audio, to try to cover all those topics. Due to the nature of this webinar, there is, of course, sometimes audio in this webinar. If it is too loud in comparison to my voice, please let me know via the Q&A section or via the chat window. I'll try to adjust it. So let's talk about audio. And I'm going to mention this audio related. And why do I mention it like that? Audio is, of course, normally, an audio wave, and music is, I guess, the best example. But we hear sometimes that when people ask us about audio, they mean all types of things. So let me further explain that. Sound effects, just like music, I think that's pretty obvious. An MP3 file, a WAV file, or something like that. Something that creates actual audio. The most common ways of audio and actual audio. But there's also something like this, which is called timecode. And timecode is it's a square wave distributed via audio system. So is it actual audio? Well, it should not be used, because if you do, it's going to sound something like this. But why might people want to use this? There's actually a meaning of this. It's not intended to be listened to, but it is sharing an audio. Via audio, it's sharing time information. And every noise you hear, every frame, 25 or 30 frames per second, it is sharing the exact hour, minute, second, and frame. It is, it's identifying that. Note that at this moment, I'm playing a WAV file as timecode. That's not really the normal case. In a normal situation, timecode is generated by an actual timecode generator. But the cool thing is you can just jump back and forward, and it will always tell you the exact time a system should be playing back. There's actually different versions of timecode, all with their own special characteristics. That's outside of the scope of this webinar, and we'll just keep it generic to timecode. Now, there's also something called MIDI, and MIDI, to put it simple, it is used a lot by musicians, but it is commands being told to other devices within the audio scope to actually create the real sound, to create the actual audio. So, for example, if you press a key on the MIDI keyboard, it might send, note 60 has been touched with velocity 10. There is an actual other device that makes it into a sound, as if a key C4 on the piano is pressed gently. So MIDI are just commands, but they happen to be used a lot in the audio world. There's also a Ethernet variant of this, so MIDI over Ethernet, and to put it simply, that's called OSC. Now, within the MIDI world, there's also a form of timecode called MIDI timecode. I can't let you hear that, but it's equal to the timecode I just showed you. It is a protocol that is sending time across a network, but rather than sending it across the audio network, it's sending it across MIDI cables. When talking about audio, there's of course also the difference between input and output of a system. And we're now working with Pharos. Of course, we need to figure out, do people want to do something with audio in the designer software, or do they want to do something within from the Pharos hardware? Because if we look to a simple example, for example, well, let's turn some of the blocks on. If people want to use timecode, program a show against output, we are talking about getting timecode into the system. I want to set it up from the designer and run it from the hardware. This is a valid request that we can meet, and I will show you this in a second. But also something like this, I want to, based on an OSC trigger, I want the Pharos hardware to output audio, or I want to output OSC triggers from the Pharos hardware. This is something we can meet. And let's do one more. I want in designer to use music because I want to program show against a song. Yes, we can do that. But not all of the combinations I can make from this screen would be valid within a Pharos system. To continue on these concepts, I've written up a list of different concepts that people are asking us from time to time. And very well, sometimes the question is quite simple. Do you do audio and only, or do you integrate with music? And only when we start to ask, we understand what people actually mean. And the reason why we ask that is because it's quite important to understand. At high level, I could split this up in two different sections. The top one I'm calling show control. So trying to make a nice show that might include some sort of audio and lighting that where I want to play the exact same effect every day on end, or I maybe want to do, be sure that if somebody walks through a sensor, the right piece of audio is being recalled. So everything having to do with show control, as you see in sound and light shows or in themed entertainment or areas like that. At the bottom end, we have more items that require, let's call it music processing. If sometimes people ask us if we can play another show based on the type of music played. So they actually want to take a piece of music, do processing on it, determine if it's electronics dance music or if it's rock or if it's whatever classical music, and based on that, play back a show. Pharos is all about show control, and everything related to music processing is not something that we can do. I mean, we can integrate with other systems that can do it, but we don't do it ourselves. Some of these parts that are exactly at the edge, I mean, it's literally a gray area, hence putting the gray block behind it. Yes, we can do some parts of this, but if it's meeting your project requirements, that's difficult for us to judge. I will give examples in this webinar of the things we can do, and if this is sufficient, based on project by project, you can probably decide that yourself, or you can let us know. We can try to help you make that call. I'm going to take you through these examples. I'm going to show you how this is set up in Pharos. And the first part is related all to the Son and Lumiere shows. In that case, the setup is quite simple, right? There is a lighting installation and people want to program a nice show against music. We can do that, and we can do that relatively simple. The cool thing is for this, you only need the designer software. You don't need any specific hardware. It outputs just via your computer audio, and this is just a convenient way to create, to create a show. I've started already with the project file. There is a layout in here. The timeline is still completely blank because this is where I want to create a nice show. But I'm going to jump directly to the simulate window. And over here, I'm going to click this little tick box called Enable Simulation Audio. If I now go back to the timeline, you see there's an additional row on my timeline. And over here, if I go to the Media tab, I can now import songs, MP3, WAV files, things like that. And I can put these on the timeline, just as you're familiar with doing it on other presets. I have the ability to adjust the exact start or stop time, so I can skip an intro or an outro. And of course, I need to add the duration. In this case, I'm just going to make the length of the clip the same as the original song. If I now play, we simply will hear the audio track, as simple as that. I can mute it via the button on the top, or unmute it again, and like that, hear the audio. I have the benefit that I can, let me make the audio a bit softer. I have the benefit that I can just jump to the right position on the timeline and it will start to play that instantaneously. So very simple to over and over repeat the relevant elements. There we go. Now let me put some effects on this timeline. And to start this, I'm just going to make some very short red flashes that last about half a second fade in, half a second fade out. And I'm going to put them at the beat, so to say. I know the first one was at the beginning, so that was pretty simple. The next one was about 2 seconds later, I think, something like that. But you see, I have the wave curve at the bottom of the screen to figure out what is exactly happening. And as you might see, I'm sometimes zooming in or out. I can do that either by adjusting the cursor on the top, but I can also do it by holding the right shortcut button, which is Shift, if I recall correctly. This is a recording, but I'm pretty sure it is Shift. Otherwise, play around, you'll find it. Like this, I can put all the different presets at the right moment. I can play it back, and I think, yes, this is indeed, this sounds right. I can see that the waves, it's matching up, or I can simulate it over here. And we see the lights turn on at the right moment in time. Now, of course, I don't need to use just simple blocks of color. I can also use the dynamic effects and make that link up. Let me use the wave preset, and I want to make all those same fixtures just flash on in white and then slightly fade to blue. To do that, I'm gonna adjust the wave properties. So I'm gonna put it to ramp down. There's 36 fixtures in this group, so I'm gonna make the body. I'm gonna make the body to 36. Yeah, so that starting point seems to be more or less right. I'm going to change the rest of the timing to make this line up. And because you have the waveform at the bottom of the screen, it's pretty straightforward. Again, let me reduce the audio a bit to set it roughly the same time. And then by zooming in, you can make it match better. A question that just dropped by is if we can enlarge the sine wave any further. Unfortunately, we would love to do so. We might in a future version, but it's actually quite a lot of work. And at this time being, this is the waveform as we support it. But you'll find out in most of the cases, if you zoom in, it will give enough detail for you to program against. So I adjusted the rest of the preset, and because I have adjusted this preset and I found out, what the timings are, it's actually quite simple to now add additional effects to it as well. Because I know the loop time can be exactly the same, because the beats, of course, are, once I know what the beat interval is, I can adjust multiple presets to have that same timing. Let me zoom in a little bit to be sure that the starting point of this effect is right. And on this one, is maybe important to mention that when you move a preset over a timeline, by default, we are snapping at 0.10 seconds precision. But if I'm holding the Shift key, I can position presets within 100ths of a second, so I can make it match exactly at the right moment in time. Let me simulate this. Oh, and turn up the music a bit. And in a second, we will get the additional wave on the facade to enter. Oh, that was a bit further, I forgot. Normally, of course, if you have a larger screen, you can conveniently put two windows side by side. But in this case, in a webinar, that's kind of tricky. Yes, well, I think this gets the idea, right? You just create a timeline, you put the audio at the bottom, and you can program your effects against it. Of course, you can make multiple timelines, all with different songs, different shows, etc. The simulation audio will only simulate one piece of audio at a time. So if you would make a soft trigger that starts 3 timelines at once and try to simulate that, it will only simulate the last audio based on the last timeline that was started. Yeah, I mean, this is of course the basics, right? So I can put audio on a timeline, but that helps to create a show. But in the end, you want to be sure that it's played back at the right moment in time. So let's look at the real first use case where you have a sound and light show and you programmed a nice show against music, but now you want to make some triggering to make it link. To do that, I go to the trigger page, and at the trigger page, of course, you can say there is an incoming system. This is just normal Pharos triggering that starts this timeline, right? Timeline 1 is the timeline that has my show. Maybe there's some serial trigger coming in or some audio triggering coming in from an external system that makes us start the lighting. Pretty straightforward, I would say, the normal way from integration. But there's also, of course, the other option. Let's say there is a trigger in our system and we want to both start the light show, but also send a trigger to the audio system. For example, a serial string. Let's say you do this and you go testing and you find out that every time when you send actually this output to the serial system, it takes about 1 second for that audio system to start. So you need to bring the system back in sync. Of course, you can take all the presets on your timeline and move that 1 second later, but there's actually an easier way. You can just adjust the timeline offset. And if you do this, you see now this timeline is starting at 1 second in time. And like that, it is synced. It will be synced up better. Let me just put this back to 0. But of course, you can imagine this way of integration is not ideal. I mean, if you have 2 completely separate systems, it's hard to rely that the triggering goes at the right moment in time. So let me go to this second example. A very easy way to be sure the audio and lighting is in sync is if you're using one of our 19-inch controllers, so the LPCX, the VLC, or the VLC Plus. Those have a analog audio output. They also actually have a digital, the SPDIF output. This allows you to program audio directly on the device, and at the moment when you start it, it will output both the light show as well as audio via the analog outputs. Let me show you how that looks. I go back to a similar show. I have my timeline, but as you can see, I have the simulate audio disabled. But I am working with a 19-inch controller, the LPCX in this case. I go to the project features and I make sure that I enable timeline audio. Because once I've done this and I go back to timeline, I get a similar row as I had before, but this is now resembling the audio output of this controller. I take a piece of audio, put it on the timeline, similar like I did before. And if I now would play back the timeline, make it a bit softer. If I now play back the timeline, it will output the audio via the designer system. Of course, that works on the simulate page as well. I have the option to also turn enable simulate on. This will create an additional row, but that will probably cause for confusion. So this is actually not a very likely use case. Yeah, well, let me stop this. And just to show you, if I would add another controller, because maybe you have a big installation that's covering a lot of different areas. If I would do this, I would simply get another row of audio where I can program against for the other controller. And of course, that can be on the same timeline, that can be on different timelines, multiple options possible. Now, if you're programming on audio on a controller, you will note that there is actually you don't need to worry about syncing anymore, right? Because if you go to your triggering, as simple as starting a timeline, when the timeline is started and it will play the lighting, it will simply play the output at the exact moment in time. Volume can be set like this, which is pretty straightforward. If you enabled audio, you will also have received these Z volume triggers that allow you to set the volume on the controller, or if you would enable the controller trigger edit, enable it to every controller individually. Another feature that you might have noted, if you're using really audio from a controller, you have the ability to set the audio category, and we have 2 options to choose from: background and alert. And I think the names probably give it away. Let's say I created 2 timelines. Timeline 7 is a background timeline with background music, and this timeline number 8 is just a very short audio track in the alert category. If I make 2 triggers, one to start the background and another one to start this alert, I can simulate this, and you will see that this alert will be played back on top of the background audio. Let me show this. I start the background audio. And when I hit the alert, this will be slightly played on top of it.
Please mind the gap.
This is convenient for the simple, let's say a fountain or something like that, where you want to maybe have a background music and also say at real time, say that the show will start in 5 minutes or in 2 minutes, or you maybe want to have a sensor if people cross a certain line to play a certain alert. So our hardware actually has 2 audio players. You can play back one piece of background and one piece of alert and one alert layer at the same time. Okay, this is a very convenient way to sort straightforward sound and light installations. But if it's really down to quality, you can imagine that a lighting controller that's able to output audio is not sufficient for those more advanced installations. And in those advanced installations where lighting and audio, or maybe even other systems like fireworks or animatronics need to be aligned, in that case, people use Timecode. As we can find on our website in the which controller do I need section, so under products, you have a which controller do I need section. There you can scroll down and can see, okay, I want to use Timecode. If I want to do that, none of our controllers support that natively, but all of our controllers can do that by adding a Rio A to the system. How would such an installation look? I have a Rio A, I connect that via Ethernet to my controller. And of course, there needs to be some sort of timecode generator that is connecting via audio. I connect it to the audio inputs from our Rio A, and I'm good to go. Let me show you how to set that up in Designer. Again, I have a simple show. I still actually, I've done some pre-work, so I use the simulation audio feature to simulate audio to the right show. But now I'm on site and I actually need to connect the hardware and make it link to timecode. I already found controller. I'm waiting till, Designer also now found the remote device. I'm adding a remote device, and this is being associated automatically. So I can see I have my controller, and my controller has a remote device, which is the Rio A, which is currently online. In the properties, I am going to change to make the Rio A used in timecode mode. And I'm selecting the channel. I mean, audio, as you know, stereo has left and right. The timecode signal can be on the left or on the right or on both signals, but you need to select one of them you want to listen to. And you need to select the bus you want to route to. Pharos is actually supporting 12 timecode buses simultaneously, but I guess you hardly ever need that limit. In many cases, one is sufficient. Then again, we have customers who actually use all 12 of them. If you're routing timecode to a bus, you see at the bottom you have these 2 options to regenerate frames or ignore jumps for amount of frames. Very simply said, this is allowing you to make sure that even if your timecode signal might not be very optimized quality, you will still get very continuous playback. But in a proper quality system, you should be able to just leave both of them at 0 frames and run without any issues. Yes, I mean, I can change frames, but let me just keep them at 0 at this moment. So if I upload this to the controller, I'm making sure the controller knows I'm connected to a Rio A, and the Rio A knows I'm configured to use timecode. With that done, I can open from the menu on the top, I can open up our timecode viewer. And because I now actually am playing back, or I have a timecode generator that is playing timecode, I can see the code that's being created. And also when I jump on that timecode generator, you see the jumps are correctly followed up. It also shows me what format of timecode I'm actually using, which is convenient. I need that for setting up the timeline later on. Let me close that and actually set up my timeline. Because if I go to the manage mode and I have this timeline selected, I can say the time source, I want to change that from internal, so from the internal clock from the hardware. I'm going to change the timecode to my timecode bus number 1. I select the format, which is the similar as I showed I'm using at this moment. I'm going to make a very simple trigger to say, when you start up, play back this timeline, and I'm going to upload this to the controller. I'm turning off timecode right now to show you something, because if I'm uploaded this, you see the timeline is started. It says it's running, but the time is just static at 0. Why is that? The device itself is listening to timecode, but at this very moment, I'm not sending any timecode. So even though the timeline is, completely up and running, it's just playing back the frame 0 because it hasn't received anything. Now, if I start timecode, you see it will just start to play back the exact frames of the timecode that is sending out. And you might note that the timecode I was using for this webinar was starting at 2 minutes and 15 seconds. And the timeline so far I just programmed to start from moment 0. So at this moment, I'm not actually outputting anything. And let me show you how to adjust that. I'll go back to the timeline settings, open the manage window, and I'm going to put my time offset to the right moment of timecode. Why is that? Many systems don't support multiple timecode buses, or they have other reasons why it's convenient to program different shows at the same timecode bus, but different moments in time. This particular show, so to say, or this particular show element is being started at 2 hours, 60 minutes and 50 seconds. So I put that as my timecode offset, and I can, right now I'm sure that I'm playing back the exact moments that I wanted to play back. The other thing to note is that when you make a timeline set to timecode mode, you're now not longer programming in 100ths of a second, but you're programming in frames. So you see, if I move this, the last digit on the time bar is going from 19, 20, 21 to 24, and then back to 0 again, because this timecode has 25 frames, 0 indexed, meaning 0 to 24. So you really program exactly to the frame in this case. I can, of course, still use simulate. Let me simulate this timeline. And of course, normally if you play simulate, I entered the timecode offset. So now it will start to play from 2 hours and 60 minutes, 15 seconds onwards. But I can also say, I want you to listen to the time source. When I'm actually connected to the Rio A hardware and it's correctly set up, I will have the ability to say I want to listen to a timecode setting, and now all the effects are following the timecode that is out there on the network at this moment in time. The refresh rate, as you show it in simulate, is as our simulation, that's I think at 15 frames per second, so that's not at the same refresh rate that our controllers operate at, but it will be sufficient to get confirmation that you programmed it in the way how you want it to look. So that's the basics of timecode. And again, for more professional installations, timecode are really the way to go. Let me now go to MIDI, because I'm going to keep this very simple, but I mentioned to you there's also this concept of MIDI timecode. And the benefit is that our LPC controllers, so the DIN-rail controllers, they also have a MIDI input, so they can support MIDI timecode natively. How would that look? Well, as simple as that, but rather than going via an audio cable, there are these MIDI plugs that you can put directly into your Pharos controller, and now it can understand, well, MIDI signals, and that means it can also understand MIDI timecode. Actually, I have a few slides to show you how to set that up. If I would use a Rio A, there's MIDI plugs on the Rio A as well. I can just, in the MIDI section, select what timecode I want to route the MIDI timecode to. And of course, when I do that, I can choose again if I want to generate possible frames in case of jumps or not. If I want to set it up on a LPC, I simply select the LPC, go to interfaces, and in the MIDI section, I can, like that, link MIDI to a timecode bus. The rest on timelines and simulations and everything, it works exactly the same as I showed before with the linear timecode. while touching on MIDI, as I mentioned to you before, MIDI are just commands that are being sent around, and OSC are just MIDI over Ethernet commands that are being sent around. You know, Pharos is great at integration, so it means we are also good and have lots of options to integrate with MIDI commands or with OSC commands on a network. A simple example, right? I went to the list, I selected some MIDI triggers, and if I select a MIDI trigger or a MIDI action, I can put them to the list. The only thing that is slightly different than what you might know from, for example, Ethernet triggers or serial triggers, we have a dedicated MIDI message builder that is allowing you to to say what type of message you would like to receive. Yeah, I think for everybody who has worked with Ethernet, with triggering in Pharos, especially if you use serial Ethernet triggering, this will look pretty familiar. This is just a tool to help you build that message. But in the end, it's all about when Pharos receives a certain message, do a certain action, or when we based on a certain trigger, output a certain action. OSC is integrated via our I/O modules. So enable I/O modules, click download, search for the latest version of the OSC module, and download this. This is now available in your library, and like this, you can add one or multiple instances of OSC. So right now, I'm going to make 3 different OSC samples, all with different output ports and input ports that will all work parallel on a single controller. When you're working with OSC, you will get input and output triggers available in your trigger and action list that you can program, well, in similar styles as you could program any other trigger in our system. So right now I've covered, some of it quite short, but I've covered the 6 initial topics. I do want to take the rest of this webinar to show you what is possible in this gray area. So I do want you to show what audio options Pharos has to take in audio to the system and make effects based on that. Again, I will we are able to do things, and that's what I will show you, but we are not able to do really music processing. So let's say something simple like, or what sounds simple like, I want to detect the beats per minute and make my lighting playback at that rate. It is not something we natively support. I mean, there are some ways to do it, but I would typically say if that's what you're looking for, there are better systems for that purpose, or there are systems out there we can integrate with. As a nice example, real-time audio processing is quite hard, but there is this external application on the market that real-time detects music and is able to send MIDI commands for every beat, bar, and atom. So, you know, let's say every beat, the main beat, which is typically every 4 or every 3 beats, and the atom, so let's say like the hi-hat sound, external device can do that processing, sending us OSC triggers. That's probably a much better way to get there. But then again, there are situations where just reacting to music is what you want to do. And let me start with a very simple application. Let's say you have a stadium and people want that at certain moments in time, the intensity of the pitch lighting goes up and down with the crowd cheering. So with the amount of volume the crowd is creating. Of course, there is a audio system already available within the stadium, but we need to get that audio signal. So let's say, to say it simple, the microphone, we need to get that into our system. To do that, we need to have audio input in our system. Our boxes don't support it natively, but with the Rio A, we can do that. The Rio A is able to analyze volume in a very straightforward way. Volume is being analyzed into a 8-bit value, and we can analyze different audio bands. So let's say the bass, the treble, and what is it, the bass, the mid-range, and the treble, and analyze how much that is available as an 8-bit value in Designer. How does that look? Well, this is how you set it up, right? You have the audio. Audio is coming from an external system, and just note that you cannot directly connect a microphone to this system. There needs to be some sort of audio system in between. But again, I'm pretty sure that if you have this type of applications, these audio systems will be available. We just need to be able to receive a signal from that audio system. But let's go back to this example. Let's say these white lights, I want to link up to the volume of the audio signal coming in. In order to do this, I'm going to make a simple timeline where I'm going to first turn the lighting on, right? I select the lights and I make them come on to 100%, and then I want to make a trigger to play with the volume. Let me first make a trigger where I'm going to start up this timeline. So on startup, it will start to play this timeline at 100%. And now I'm going to a network and I'm going to say that I want to use this Rio A in audio mode, not in timecode, but in audio mode. We are able to support 4 audio buses simultaneously. Right now, I'm just going to simply simulate or route this to audio bus 1 and upload this to the controller. Once I've uploaded this to the controller, I can, just as with timecode, I can go to the hamburger menu and I can open up a timecode, an audio viewer. If I open this, I can see a graphical representation of the audio that's coming in. And right now I am actually sending back a piece of audio. So that is what the Rio A is analyzing. What Pharos is doing, and I'll just pause the input, but the volume is a value between 0 and 255. Band number 1 is a value from between 0 and 255, etc., for all the available bands. And it's these values that we're able to use in Pharos and either use in the triggering, what I show you now, or use at the timecode at the timelines, which I'll show in a second. If I go to the triggering, I select the audio input trigger. I select the Rio I want to use. I say I want, well, which channel do I want to use? In this case, this is just combined. And I say I want to use the volume. I have the option to select the peak signal as well. Peak signals go up quick and ramp down slowly. If you might, it's just a different visual result. I set this up that every time when this value changes in range, I want it to link to the master intensity of this group of white fixtures. So I need to say the intensity is linked to variable 1 because that's the variable captured in this trigger. Now, with most of these type of triggering, I cannot simulate this in Designer itself, but if I upload this to the controller and I'm going to the web interface, I can show you how it looks. The one thing I just want to show in between is, in this case, there's a very big chance that I don't want to always use the audio to control the intensity of this lighting. And at moments, I don't want to listen to the audio input. I just want to control the intensity manual. In that case, I also have an additional audio trigger that is allowing me to toggle the audio coming from the Rio A completely off or on again. So, I mean, a simple way to say, you know, please shut up and don't send me any new information, or please do send me all your audio information. Let me go back to what I showed before. Upload it to the controller, open up the controller's web interface. And if I now look to the whites intensity, you can see that the intensity of this group is just moving up and down very quickly together with the volume of the music. So the yellow bar over here. There is an other way, however, to use this to make more effects. And to do this, I want to use, or I'm going to create 8 different groups. And you see I have those groups created here. And I want to make a graphical equalizer on all of these 8 groups. To do this, we can sort this at the first thing I need to know, of course, I'm getting in 8 bands of audio. So I'm adjusting my Rio A audio setup to actually listen to 8 frequency bands, or to calculate 8 frequency bands. And next, well, let me just upload this and actually show this. Right now we have 8 frequency bands. But in order to link every band to a timeline, I can do this actually at the timeline settings. So how does that work? Let me just remove this trigger because I don't longer need these ones. And let me go to a timeline. And if we go into the timeline setup, I have the ability to link the timeline source to the audio bus. And what this means, this will use the 0 to 255 intensity from volume to set up the position on my timeline. So in this case, I'm going to link to the base, so to the lowest band, and I have a 10-second timeline. If I play back audio, the position of the timeline will extremely fast, vary per frame, vary with the intensity of bass that is being discovered in the audio. Now, a wide timeline is of course a bit dull, so I created this other timeline, and let me show you in Simulate how this looks. This is how this timeline looks if I play it back with normal time, right? It's a fading in of a green to red gradient that's fading in from the top to the bottom. If I would now link this to my timeline setting, which is audio in this case, I will get an effect like this, which is one band of a graphical equalizer. I have created not just one, but I've created 8 timelines. Every timeline is linking to a different part of my facade. And of course, I set up in the manage section that every timeline is looking to a slightly different audio band, 1 to 1, 2 to 2, etc., etc. And let me, so this one's looking to 2 because of this to group 2. I make a trigger to start all the timelines at once. As you know, Pharos is able to play back multiple timelines at once. And if I'm going to simulate this, we now have a graphical equalizer. Why is that? Every piece of audio, every piece of, every timeline is looking back to its own part of the audio. And like that, it's well, simulating on my computer, or if I would actually connect this in the outer world, it's outputting the relevant values. Let's make another effect. In this case, I have a rainbow background. I'm putting some other timelines with a black with transparent effect, but I do the same trick. I make a whole bunch of timelines and I link those up to different pieces of time, to the different parts of the audio. I create a new soft trigger, which is trigger number 2, effect number 2. Effect number 2 is starting 8 completely different timelines. If I'm simulating this, I will get an effect like this. You know, I have a rainbow going on the back, and I now have these top positions moving with the music. One more example. I have created here 9 groups of 4 fixtures. And for every fixture, I'm creating a simple timeline where this group of fixture, this single group of fixtures is changing from one color to the other color based on the amount of, based on the music played. I made a new trigger. I mean, this is on a different set of lighting, so I just decided to toggle additional timelines. And if I'm now going to simulate, we will see an effect like this happening. And I'm going to pause for a second, have a look to the first 3 blocks and the base of the music, and you'll see how this starts. This is the intro of the music, no bass yet. Here we go with the bass music, and that's when it kicked in. Let me just replay that so we can see how it looks. And apparently I didn't have the sound matching to it. Ah, here we go. Yes, with a little bit of sound now. And we see on the left top, together with the bass, the lights kicked in over there. Now, if this is sufficient or not for your project, that's something I can't judge. Again, all these audio triggering is coming as a additional benefit because Pharos is doing all these timecode buses and we're supporting linear timecode. But sometimes it can be nice to, you know, as mentioned in a stadium, do some additional effects, or maybe at a certain moment in time, do some other fancy lighting. Just one more example, because it is possible to also use the trigger page. Over here, I made a very simple effect, and this effect, as you can see, it's only lasting half a second, it starts bluish and then fading out to black. So another way to use to use audio input, I now made 8 of these or 9 of these timelines. I set up the triggering to say once I receive a lot of audio at a certain band, and when it enters the range between 100 and 255, so when the audio in a certain band goes high, then start a timeline. Another way to use it, if I use it like this, again, because I'm going via the triggering page, I will need to upload it to the controller, but I can show you how it looks on the web interface. That right now, every time one of the audio bands is going above a certain threshold, it is starting that timeline to play back this very short timeline effect. Again, different ways to use it. Very often it is a convenient way to just get customers who want some dynamic but don't need anything extreme, to help you out and make this deliver to your customer what the customer is looking for. So just to recap, when we're talking about Pharos and audio, there's a whole set of different ways what audio can mean. When it comes to show control, so creating nice son and lumiere shows, Pharos has different ways how to make it happen for every budget, either two completely separated systems, playing back audio or sound effects directly from a Pharos controller, or integrating with professional systems via Timecode. When it comes to send out MIDI or OSC commands, Pharos can do pretty much everything you want, probably. I mean, our integration is what we are known for. When it comes to reacting to music, yes, we can do some things, but really try to understand what the customer is looking for, because this can be a bit of a gray area. There are things possible, but it's not always easy to set up. And there are also some other elements like, trying to real-time detect the genre of music, or automatically creating a scene based on the beats per minute of the music or something like that. That's just not something that we do. Pharos is about show control, not about real-time music processing. With this, I'm coming to the end of the webinar. And if there's any questions, this is the time to ask them. I mean, one question has dropped by. We answered that. I don't know if there's any other questions at this moment. Feel free to ask them. Because otherwise, I mean, we have been on for about 50 minutes. We will be rounding down this webinar. Maybe good to mention, of course, if a question comes up after this meeting, you can always contact us at support@pharoscontrols.com, so we can help you out. And also, if you have a user who wants to do something with audio, you understand what he wants, but you're not sure if Pharos can do it, or if you're better off maybe integrating with other equipment, just let us know via our support email, because we'll be happy to help you out. There's no additional questions coming in, so I think I'm going to round up. After this webinar, you might receive a small survey where you can provide feedback and suggest other topics for the webinar. That feedback is very much appreciated. We're really looking into it and see what other future webinars we will be planning. So yes, your feedback is very much appreciated. Well, I guess this is it for today. With this, I'll be ending this webinar. I'd like to thank you for your attendance, and I hope to see you next time.